guess for those of you who don't already know me, I'm Dave Shuttleworth, currently working with EXASOL. A bit more about that later on. Jim asked me to talk about this stuff, so what I'm going to cover this evening, very short intro, and then on to the meat of the thing. Really, some observations of the current work I've been doing over the last 2 or 3 years with hybrid sort of solutions combining SQL with various NoSQL databases and the way those are being used from the customers that we're working with. One case study with a bit more detail, King.com. Those are the people who do Candy Crush Saga, in case you don't know them. As you can imagine, they've got humongous amounts of data, and I'll talk a bit about how the journey they've gone through, combining the NoSQL stuff with SQL as well. And finish off with a few observations of what I've seen that's emerging that is relevant here as well, which may or may not be of interest. I'm going to go through the slides quite quickly, given the level of experience in the room. But if I'm going too fast, or if you've got a specific question, there is time for Q&A at the end. But I'm happy to take questions as we go through. And if it turns out that the answer is going to be a longer conversation, we'll push it back to the end. But please feel free to ask questions as I go through, if you want to. First of all, a bit about me. Probably to start with the bottom. I used to have a real job. I used to write code and do analysis and design for a UK retailer when I got out of university a long time ago. After 5 years of that, I jumped into the dark side and started working for IT vendors. Originally with a company called Data General, who some of you may remember, a long time ago. And then, following that, into the world of databases, big databases. So I worked at Teradata very early on when they came across to Europe for the best part of 4 years. And then moved into a UK company who was called White Cross Systems at the time, now called Cognitio, still there. Back in 1992, it was just turning from an R&D project into a commercial venture. And a bunch of people, actually ex-Teradata, moved across to help them move from an R&D project into a commercial product. And that's, as I say, that's still there, now under the Cognitio banner. After 11 years doing that, formed Intelligent Edge Group with a couple of colleagues. This turned into a sort of boutique systems integration house, specialising in big data and databases, MPP architectures especially. And we were technology agnostic, so we work on lots of different databases, all the usual suspects. But we particularly got a lot of work implementing the earliest Netezza systems in the UK. And so the first 6 or 7 of those in the UK, we probably had a hand in doing the implementation and migration of that. And finally, 18 months ago, we decided to actually jump ship from Edge because we found this fantastic new technology called EXASOL. Quick show of hands, who had heard of EXASOL before seeing it on the agenda tonight? As many as that. Great. Okay, so I feel duty bound to do at least a bit of a background. It's software, it's a database product, it's a SQL database product, and essentially it's characterized by being columnar, in memory, massively parallel. So the way I sort of see this sort of thing is that it's like a third generation of these MPP products. The first generation being Teradata, very big, proprietary, expensive, but doing things that you couldn't do any other way at that time. Second generation was the appliance stuff, so Netezza is the classic example, making things simpler and cheaper. And the third generation is this sort of stuff, software only, probably data in memory, probably massively parallel, and probably columnar. And we actually work with a number of these products, there are quite a few of them out there. But this we see as the best of breed of this third generation. That's the marketing blurb. The reason we feel we can say that is if you look at the TPCH benchmarks. You're probably familiar with TPC benchmarks, Independent Transaction Processing Council. They put together a whole bunch of different benchmarks. It used to be OLTP, literally how many transactions a second can you do. In the later days, they put together a broader spectrum. This is TPCH, which is a decision support benchmark, so a complex set of BI analytic type queries. And so you get the idea. Basically, to actually publish these, it has to be independently audited, and it's full disclosure. So you can go to the TPCH results website, click through, and you can see exactly the hardware and software configuration and how much it cost. Because it's not just raw performance, it's price performance that they measure on as well. So that gives you a flavour of why we jumped ship and joined EXASOL. That's what I'm going to say about that. If you need more info, check out the EXASOL website. You can download a community version for free and try it out yourself, or come and have a chat in the actions. So on to the main bit here. As I say, what I'm going to talk about really is sort of things that I've seen over the past 3 or 4 years working with customers and potential customers around this sort of area. Obviously from my background, it's very heavily SQL biased. But that's, these days that's not enough. You can't, pretty much everyone we talk to when we go and talk about EXASOL these days has already got some other database stuff in there, non-SQL databases. Obviously lots of Hadoop. And King's a good example of that. We'll come on to that. So, I'm not going to read through all that, you'd like to know. Really just setting the scene, but given the experience in the room here, you probably know all this. But interesting stuff, lots of different technologies and things coming together over the last, I guess, 5 years to bring a very different way of doing things. Gone are the days where you actually pay a lot of money and stick some massive mainframe or something inside your own computer room. Some people still do that, but most people these days are at least looking at other alternatives, cloud being an obvious thing. And most of the products that are out there, whether they're SQL products or whether they're a NoSQL product, will probably be able to run in the cloud and start to take advantage of some of those things. So all the benefits of, cheap implementation, at least at first, flexibility and scalability, all of that sort of stuff, without you having to set up your own IT department and computer room and all that sort of stuff. Good stuff. And it's changed the landscape quite a lot. Having worked for vendors for the last 30 years, things have changed very, very quickly in the last probably 5 years because of this sort of flexibility. If you actually go onto there is a NoSQL database.org site, and they try and keep track of what's out there and try and classify it into different types of NoSQL database. Last time I looked, there are about 155 different NoSQL products listed on there, and they break them into various different types. The list goes on. They've got some very obscure sort of types below that. I've put them in sort of order of the sort of things that we see. So obviously Hadoop is probably the most popular right now. Hadoop's 10 years old, don't forget. It's 10 years old this year. Amazing, really. So it's not surprising. It's the one that we see most of. But lots of other stuff. Cassandra we see quite a bit of. Mongo there as well. The graph stuff we're starting to see. That's probably the lead, of all those things that are up there with examples. That's probably the sort of smallest or the least used right now. Anybody actually using any graph databases? Real? Right? Over there. How many people are using Hadoop? A few more. I think. We see Hadoop in pretty much every account that we go and talk to these days. Maybe not being used in anger yet, But people are using it as a way of trying things out and just getting to grips with the technology. And the reason people are starting to do this are all of those. Obviously the flexibility. You don't need to predefine your rows and columns up front. And that, a lot of people have been bitten by that, and a lot of the cost of more traditional systems is because you've had to define your data model, and there's all the different ways of doing that. Because historically, with SQL in particular, these things tend to be pretty fixed, and there can be quite a lot of expensive maintenance to go on if you need to change that model downstream. And of course, given today's environment, things change quite a lot. So the idea of having some sort of way of storing data that's efficient, where you don't have to define that up front, in theory sounds like a good idea. And in practice it can be a good idea as well. Also, if you're not having to take in a stream of data and break it up into rows and columns and do various checking on it, it means typically that you can write things away to disk very, very quickly and persist them on disk. So it's pretty good for things like streaming real-time data, because you're basically just dumping blocks of data and then you can sort them out later, is the theory. And of course, there's a whole bunch of data out there now that's getting more and more used or required to be used that doesn't usually match that nice row and column thing. Unstructured and semi-structured data maybe coming from machine-generated stuff, or maybe Twitter feeds or whatever. Those textual things are a good example. You can stick a bunch of text into a SQL blob, but you've still got to then sort of dive into it and try and make sense of it. And some of the different SQL database types would say that they've got a better way of handling that sort of stuff. It sort of maps quite well with the sort of cloud elastic sort of idea, and the idea that your processing load might not be consistent throughout the day or the year or the minute, and so the ability to scale up and down on demand is also a thing that people are looking to do these days. We've got a classic case with a client we're talking to recently, Marketing Services Bureau, and Monday and Tuesday are their peak processing days. And the processing and resources they need to do their complex processing on a Monday and Tuesday are probably about 5 times the amount of processing resource they need for the rest of the week. So the ability to have an environment where you can scale that up and down to fit and not have to pay for resource that you're not using is obviously quite attractive to them. And a combination of some of these NoSQL environments and the cloud lets them do that. I have to say that some of the SQL environments are also capable of doing that. Most SQL environments these days are relatively easy to scale up, because they're hoping that this thing grows, and they put a lot of work into making it easy to grow the size of the database without having to do massive sort of retooling. Typically they're not so clever at scaling down, so they're not typically quite as flexible as some of the NoSQL environments for that dynamic thing where you want to scale back when you're not using the format and resource that you might need for your peak times. Obviously, most of these things are designed to run in parallel on distributed clusters of cheap hardware. That's one reason why they've been sort of touted as a cheap way of doing this. One word of warning: I would say it's easy to start out and use this for trying things out, in the same way that it's easy to, for example, put Redshift up on AWS and get yourself a scalable SQL environment. If you actually do the costing for a relatively, a production level requirement in terms of data volumes, in terms of resilience, then it can get quite expensive quite quick. Be aware. But a lot of these things are now designed to build on top of distributed processing and have high availability. So fault tolerant at various levels, so that if you need 24/7 uptime, then these things have got got that designed in. You might end up paying a bit more money for it because it might need more hardware to give you that resilience. Just going to zoom into Hadoop as an example of one of these, partly because it's been around longest, and it's also the most frequent of these things that we see out there in the field today. But use it as an example of where it started and where it's got to now. You could substitute probably all of the others in terms of the stage of development and some of the ups and downs of the development. It began way back 2005 with the distributed file system and the sort of idea of MapReduce, splitting down processing and running it across a distributed cluster of processors. Lots of bolt-ons emerging. It's tricky keeping up with all this stuff. I find it tricky, I don't know about you. All the different layers and additional technologies that are being built around this to address some of the broader issues. Initially, I'm not going to go through, you can read those as well as I can. It was invented to do one thing, really. It was basically, Doug Cutting, who was working at Yahoo at the time, was looking at a way of indexing the web and providing a scalable way of doing that quickly. So that's what it was built, that's what it was designed for. But people sort of embraced it and started using it for things it wasn't designed for. And that caused some problems. And, if you look at the old Gartner curve of introduction of new technology, it went into that sort of bit where the expectation was high, and then it's dropped into the dip where people are trying to overstretch it, and it's not delivering what they expected. If you use it for the sort of thing it was designed for, it's pretty good. But if you try and do things that it wasn't designed for, then it's maybe not so good. For example, extreme cases to make the point, really, you wouldn't think of using Hadoop to address these sort of things. Well, I wouldn't anyway. And also, there's a case to be made for the sort of meat and drink of what EXASOL and some of the things like Teradata and Netezza have been used for in the past, analytical queries. So analytical queries tend to have these sorts of characteristics. Quite often you've got a whole bunch of detail level data, be it transaction data or whatever it is, and quite often what you want to do is group it and aggregate it. Maybe doing max and mins and various other things on it. Very, very obvious sort of thing. And also, because of the way that in relational world data gets modelled, then you quite often have to join tables together and do things like nested subqueries to actually get the precise logic that you need. And it might be individuals, real people writing the code, or these days, quite often, it's not an individual writing the code, it's some sort of visualization tool at the front end or reporting tool that you point at a relational model, and it will generate dynamically SQL to do what you've asked it to do, draw a graph or plot some stuff on a map or whatever it is. Behind the scenes, it's going to be generating SQL to do that sort of thing. And quite often, these sorts of queries are relatively short running, ad hoc. The whole point of doing these clever things is to allow ad hoc analytical queries to be run against your historical transaction data, broadly speaking. And perhaps you've got to run lots at a time. It's not unusual to see, even in a non-web organisation, tens, hundreds, maybe thousands of concurrent users these days. And of course, if your front end is the web, then potentially you're going to have many, many thousands of concurrent users. And the good news is that in the SQL world, SQL's been around for a long time as well, more like 25, 30 years rather than 10. And a lot of work has gone into actually making these things run quickly. I remember way back, front page of computing, I'm trying to work out what year it might have been, but some IBM DB2 relational database on mainframes in those days, they just managed to achieve 12 transactions per second. And the project manager had sent the lead developer, who happened to be a lady, 12 red roses because they'd managed to do 12 transactions per second. A bit different these days. You saw on that EXASOL slide, we're up to something like 5.5 million complex transactions an hour. You know, and that was on a 1 terabyte raw data. Some of the other characteristics that were behind MapReduce and HDFS don't quite map onto that scenario. If your query only runs in a few seconds, then the odds of failure are much lower than if you've got a 5-hour batch job. And so maybe fault tolerance, building in fault tolerance isn't quite the same requirement. And you know, a 5-hour batch job in Hadoop is by no means unusual. 5 days of jobs are not unusual. So, and also, with some of these things, there can be quite a big startup time. So if you've got a 5-hour job, a 20-second startup time is not an issue. But if your query runs in 2 or 3 seconds, then a 20-second startup time is probably not very good. And, you know, obviously, people are realizing these things and things are being done to address this. If you're into Hadoop, you'll understand all that sort of thing. Basically, 2 examples of the optimizations they're trying to do. And quite often, these optimizations are pretty well understood because they've been done already in the more traditional database world. Because the way of getting from 12 transactions per second in DB2 to 4.5 million transactions per hour on a much cheaper, smaller hardware footprint is built on things like this to optimize and make things work better. This is an example taken from this here. If you're a MapReduce type programmer, you probably understand all that. And this is a typical bit of Java that does some of the things you might want to do for an analytical query. Now, someone's probably got to write that and debug it or whatever. If you were doing it in SQL, that's the same thing. That's the same thing as that previous code. And that's obviously a very simple piece of SQL. But, you know, it's been so successful as a language because it actually is quite easy to understand and quite flexible. And because it has become standardized, then the front-end tools are geared up to work with it. So you've got a very big choice of front-end tools that will generate this sort of stuff. And because it's a standard, that means you can change the back-end if you need to anything that's standard SQL. And you know, there's got to be something said for that. Just as an aside, the sorts of tools that we see being used to generate this stuff, the big one right now for that we're seeing a lot is Tableau. Great visualization tool. Pretty good at how it generates SQL. Works very, very well. It will work. It's got its own sort of caching inside there, and so it works reasonably well up to a certain size of data, either a number of rows or raw data size. But it's also, because it's using SQL, if you hit the wall in terms of data size, if you replace the back end with something like EXASOL, one or Teaser or Teradata, then it will then scale, and you get the same fast visualization on much bigger volumes of data without having to change anything, because the common thread is SQL. So yes, trying to think when I first wrote SQL, I was still at Data General at the time, so probably in the early 80s, I think. So it has become standardized, and because it's to such a high level, it takes away all that nitty-gritty stuff. You don't have to worry about how many processes you've got or where the data is. You just do the high-level procedural or non-procedural SQL type stuff, and it will do what it does. And it's down to the implementation to make sense of whether you've got one processor or 100 processors in a cluster, and your data is, you know, one gigabyte or 100 terabytes. SQL sort of is a level of abstraction that means you don't have to worry about that sort of stuff. Now, even with my background, I'm not saying that SQL is perfect. You try and do some of these things. You know, the classic Hadoop example of doing like a word count from a document or from a stream of text coming in. If you try and do things like sessionizing weblog data, that's not very good. Or anything where the data isn't nicely structured. The S stands for structured, essentially. But if you have got data that is structured, or bits of the data that are structured, then for analytical queries, it's excellent, because it's been around for so long. It's been pummeled into shape by people who are good at this stuff. About 5 years ago, I think, Hive came out, and Hive was an attempt to put SQL-type functionality on top of Hadoop, for all the obvious reasons. For that basically, it's a standard. If you've got an SQL implementation, you can get all the benefits of the Hadoop storage backend, elasticity, flexibility, cheap, whatever. But you can then use standard tools at the front end, and say maybe get the best of both worlds. The bad news about that, it was obviously quite an early implementation, and it wasn't very good, quite slow, and not a full SQL implementation by any means. I did some testing recently doing benchmarks. The TPC one, there's a new TPC one called TPC DS, which is the next generation of decision support queries. Very, very tough tech. They basically give you a set of utilities that will generate the data to whatever size you want to run at. And then a set of utilities that generate a set of queries that are designed to get round and to test the speed of the database. But it's been done by people who understand how people used to beat the old benchmarks by doing indexing or partitioning or whatever tweaks they did. And so it's been very cleverly put together so that, you know, there's lots of different access paths to the detail level data. It's around a real world example. It's around a retail sales environment, but with different sales channels. So they've got standard stores, they've got a web channel, and they've got a partners channel. And so you've actually ended up with 3 big fact tables. And quite often you want to query across all 3 of those in very complex ways and join the whole thing together with unions. Hive couldn't do. You generate this thing and you get a list of 99 queries that get generated with random keys so that you're not hitting the same data all the time. And the idea is that you run many streams of this in parallel on your 10 terabyte database. Hive could do do about 40 of those 99 queries because the SQL implementation wasn't mature enough to handle some of the SQL constructs that were generated as part of that test. And it was, again, very immature, is basically what it was. Most of the systems out there that have been around a while have got various internal indexing methods and compression techniques to make the thing run efficiently, maybe even size of hardware. Not so much with Hive. And it's probably quite a well-known quote now from Merv Adrian, who's a Gartner research fellow. And so what you might have seen in the press is that everyone likes to compare to Hive because everything looks good compared to Hive. So just some examples: Amazon Redshift, Sharp, and Stinger, and that's Hawk over there. Everything looks good compared to Hive. And I have to say, hands up, EXASOL's no different. That's actually from a King presentation. They found that when they were doing their transformation, which they were doing in Hive, they found that on 4 EXASOL nodes would get performance equivalent to 420 Hive nodes. And that's supposedly an area where the Hadoop stuff, batch transformation processing, is supposed to be good. So yeah, we were guilty as well. Sorry about that. But yes, it's being improved. Lots of new things happening. And the sort of, from my point of view, the sort of kind of depressing thing is that if you read through those list of things, and if you've been around databases for a while, they probably sound quite familiar. These are things, it's a certain degree of reinventing the wheel going on here, to build in the things that have evolved in more traditional databases over the last 25 years to bring things up to speed. So if you're really interested, you can go and click on that page on the web and you'll see all those things.
Being a newer implementation of SQL.
Sorry?
Being a newer implementation of SQL, it's normal they catch up, that's it.
Oh yeah. Basically, I picked on Hive, probably unfairly, but it's a question of maturity is the issue. I mean, things will improve, things are improving. But I just find it kind of frustrating on 2 levels. One, that people who are developing Hive are essentially reinventing the wheel, and also the users who are actually using this stuff to write applications. Quite often, you see these guys coding in Java or C or Python or something, and you think, well, you know, you could do that in SQL in one statement, and they're having to code this stuff. It's a moving target. Things are changing. So if we wanted to find, you know, our dream architecture, what would it be? Maybe there's good reason to stick with the SQL language because of all that commonality and all that standardization. But best of both worlds, really, would be ideal, wouldn't it? Use Hadoop in the right way, or whatever underlying database, NoSQL technology or otherwise that you want to bring in there, to get the benefits of that sort of stuff as well. And also, it would be nice to have some of the security that maturity brings you. Fortunately, you probably can't design in maturity because it takes a while to actually get mature, right? And ease of use. The other thing that I see with a lot of these NoSQL implementations is that they can be quite tricky to set up and to administer and to get all the things that people have come to expect with a more traditional database. You know, some degree of resilience, things like monitoring capabilities, things that you need if you're going to build a production system. You probably want it to fit in with your monitoring tools so that you don't have to either use a different monitoring environment or retrain your operations guys. All that stuff that make these things production standard. Again, aren't quite there yet in lots of cases. So what we'll see right now is that you've got a pure SQL environment, which is arguably those things, less scalable, less fault tolerant, certainly less good with unstructured data. And then you've got things like Hive, SQL and Hadoop, which is less mature and less easy to use, and right now it's slower in pretty much every case that I've come across. Oops. Still working? Yeah. And so if you're trying to combine SQL and Hadoop, but again this could be SQL and Cassandra or SQL and Mongo or whatever, there are various ways you can do it, and all of these things are out there in the field right now. Some products support some or all of those things, depending on what you're trying to do. I'll go through each one. Very common, certainly 2 or 3 years ago, was to keep these things running separately and try and use a connector to join these things. So maybe you've got an option, if you're driving it from the SQL environment, you've got some way of transparently going out and dragging data dynamically in from Hadoop or HDFS or something like that. Very common, relatively easy to implement, and for some cases it works quite well. It won't be the fastest thing in the world, probably, depending on how much data you're shunting around. But low impact, and it gives you the way of doing this. The downside is that you're reliant on fast networking between the two environments to move the data back and forth. And potentially, given the reason why people use Hadoop or whatever, there could potentially be lots of data flowing backwards and forwards. And again, the early implementations of this didn't do anything clever. They basically asked for a whole chunk of data and dragged it back. More recent implementations are doing a cleverer approach with pushdown, i.e. they'll push down some of the processing into the Hadoop environment and use that to filter some of the data or transform some of the data and only bring back the bits they really need. And you really need to have that, otherwise potentially you've got massive amounts of data flying backwards and forwards. And if you do it right, if you do the pushdown right, and there's a lot of work going on with this, you can actually get a bit cleverer and get the system to work out where best to do the processing. Some of the processing might be best done in Hadoop before it then sends back the results of that into the SQL engine. And it will also work vice versa. Some people are using Hadoop as a driver and need to occasionally go out and get some SQL data. Either way works. Option 2, try and extend SQL to do some of the Hadoop type things. And most of the SQL implementations that are out there right now have for a while had the ability to extend SQL by allowing people to write user-defined functions. And that's kind of an interesting way of doing things. So you might have the ability to write in typically C or Java, Python, Lua. The one we see most of right now, by the way, is R. So you can actually extend SQL and bring your own stats functions in written in R. And so use the SQL as a framework to do what SQL does, but build in some of your own custom code written in R or whatever it is. And so the implementation lets you run that sort of stuff within the SQL environment. Quite powerful. And that could involve going and grabbing some data from an external system as well.
It's interesting you bring up R as a language. It almost puts in the front end. You see much Julia being used.
Yeah, that's one we're starting to see, but for the last, it's still quite new. In the old days, it used to be you'd have a database of some sort, And you'd probably have SAS or SPSS at the front end. And that had its own problems because SAS and SPSS would always want to bring the data back to the client and do that sort of stuff. They also invested some time into doing some of that push down stuff. So nowadays, with SAS and SPSS and certain databases, you can push down stuff into the database, which is good. Because hopefully the database is the right way to do it. It also means that you don't necessarily have to do sampling. I was on a project a while back before all this stuff got really clever, and they would do the classic stuff. They had SPS at the front end, they had a Netezza database at the back end, but basically they were having to sample because they hadn't got the push down stuff sorted out, and they literally spent 3 months working out how to do the sampling. So they spent 3 months of development time working out which 95% of data to ignore, essentially. Now I think that's got to be the wrong way to do it. Doing this sort of thing, if you can move the processing closer to the data, then, and especially with these scalable parallel engines, be it NoSQL or SQL, then it paves the way for doing that complex analytics, but on the full data set. And that's got to be better than sampling. Because sampling, no matter how you do it, you might lose some outliers, some edge cases. And people these days aren't prepared to live with that. But yeah, the thing with R is that obviously SAS and SPSS are quite expensive and continue to be quite expensive. Whereas for free, there's thousands of R routines out there on the web that you can cut and paste. And so people are doing that. And also, they're teaching R in universities now. Students coming out of university, they know R, they love it, they've been raised with it. And so R is by far the biggest language that we see people using to develop UDS for that very reason. They can cut and paste a nice stats function they want to use, maybe modify it a bit, and then run it in here, run it in parallel on full data, and get a good response time. But Julia we're starting to see a bit of traction with it.
I just saw some results that showed Julia blowing Hadoop out.
Oh yeah, I can believe it.
It wasn't designed as a big data type tool, but as a statistical language.
Yeah, that's right. And it comes back to some of those inherent design things inside Hadoop that need to be sorted. So that's, and in fact, pretty much all of the big name SQL databases have this stuff in there right now. Some of them have limitations on which language you can use, but pretty much all of them have got R and maybe Python. Lua is quite popular as well. And final option, and you see that a lot of work going on this, you build a relational database on top of Hadoop storage to try and get the benefits of the Hadoop backend storage and provide the standard front end. I've worked with a few of those. Still, I guess, immature is where I'd categorise them. But they're getting there, there's a lot of this stuff is open source, there's a lot of work going into making these things work better, so they are catching up to a degree. So, possible outcomes. I think this is probably the most likely. But this is kind of interesting. Lots of interest in Spark, which is trying to get the best of both worlds and is doing some of the stuff I talked about in terms of bringing in the accumulated knowledge from the last 25 years worth of stuff and incorporating that early, so you do get some better efficiencies, and it's not as immature as Hive or Impala or that sort of stuff. That's definitely one to watch out for, I think. A couple of things carefully chosen to reflect my own views. I'm sure you can find folks that might be different. Martin Fowler's a good guy, ThoughtWorks. Spoken to him a few times. He's saying, well, you can read it as well, I can. The rise of the NoSQL database marks the end of relational database dominance. Sounds a bit scary, but they won't become new dominators. Relational will still be popular, used in the majority of situations. Because even if you've got some not unstructured data being stored back down there, at some point you're probably going to do some transformation that gets into a more structured thing, and then guess what you're going to use to actually drive it, SQL probably. And this wonderful phrase, Polyglot Persistence, where basically a mixture, hybrid environment where you've got a mixture of SQL and NoSQL things, and the trick is to get them working together efficiently without having to jump through hoops and manually code things and all that sort of stuff. And the other, from Neo Technology. Neo Technology, the people who write Neo4j graph database. And he's pushing hard to say that, you know, a lot of these things don't have the industrial strength bits that you need on which to base a production environment. You can probably bet your life that he thinks Neo4j has. Otherwise he wouldn't say that. There you go. That was that bit. Any questions before I move on to a quick example from King? Okay. I chose this one, 2 reasons. One, I know very well, because I was involved in implementing it. And 2, because it shows some interesting things that are not unique to King. But it's a good example because of the volume and the scalability issues. So that's what I'm showing this. The slides in this section, by the way, are not mine. You can probably guess by the difference in style. These are from a presentation given by a guy called Andy Dunn, who's the head of IT at King. The IT bit is based in London. In case you're not familiar with it, King are the people who do Candy Crush, Saga, and a whole bunch of other games. They've got the top 4 games on Facebook, I think. If you look at the top 10 games on Facebook, the first 4 are from King. And Candy Crush Saga is by far the biggest. Those numbers are actually about 6 months old now. They've got more than, I was speaking to Andy last week, and he said one day last week, or the week before, they had 1.7 billion game plays in that day. What they do, every game, they collect what they call game events. And so within the code that runs the game, they spit out a little event thing. And every game that's played spits out between 10 and 15 gaming events. And they capture that real time. And so, at that 14 billion rows a day, it's nearer 20 billion rows a day now. And you can scale up those. They've got a 1.5 petabyte Hadoop environment now. And they've got, alongside that, an Excel box, which we'll talk about in a minute. So, it's big, lots of data. And they started out using Hadoop. Well, the thing about these young companies, like King, is they've only been around for about 6 or 7 years. They didn't have the legacy of having massive mainframes or even, some sort of MPP database. They started out with Hadoop because that was there, it was cheap, and that's what they did. What they actually do with this stuff, there's the usual sort of KPIs and metrics that they use for their own internal purposes. They want to measure and understand player behaviour. This is a freemium thing. Freemium means it's free. It's free to play Candy Crush Saga, but they make their money from micropayments because you can buy things in the game to help you get through the game and to make your experience better. And just to give you some numbers, you might have seen that they actually went public last summer, and effectively they got valued at $7 billion. 2012, their revenues were $62 million. 2014, $1.8 billion. So that's the sort of growth. Non-trivial. They do all the segmentation stuff you might do on it in any retail environment to try and group their players into similar groups of players, and then they use that for marketing the in-game purchases to those groups. Improve the player experience. They can actually do this. It's amazing to watch. They can see if level 76 on Candy Crush Saga, there's a whole bunch of people who are struggling to get through it. They can monitor that in near real time, and they can make changes to the game dynamically to let the right number of people through, etc. You get the idea. That's why they use all those gaming events for each game, and they use it. It's not going to stay, is it? extreme scale, rate of growth, and you know their environment. They got lucky with Candy Crush Saga. They could have been bobbing along at the 62 million revenue, which is not too shabby, for years. But they hit on Candy Crush Saga. They put it out on mobile phones and that sort of stuff, and it went crazy. So they had to live with that growth. And they want to sort of, they want to then be able to cope with the next one that they write as well. And it's a very rapidly moving and competitive environment. And so they have rooms full of PhD, data scientist type people working with this data to try and keep on top of all this. And basically, we happen to have won some business in there in the last 2 years to put the next box in there, but we have to keep on our toes. They're continually looking on the market for the next big thing. So if we're not cutting mustard, we'll be out of the door. They've got no quantum of doing that. So, in general terms, this is what they do. They have, you can imagine, farms of game servers out there. They've got, 120, 130 million active users per day, playing, last week, 1.7 billion games per day. Whole forest of game servers out there supporting that. And they get these event log files in a very straightforward TSV tab separated variable. So just ASCII text with tabs between the fields. So it is structured. And that gets accumulated by a log server into their data warehouse. And in there they keep raw data because they don't want to throw anything away because it might be useful at some point. So they've got, well, as of right now, about 2.5 years worth of history in their Hadoop data lake. And that's currently about 1.5 petabytes. They do some ETL as well to create a dimensional model where they can run their reports, and their data scientists use both the raw stuff and the structured stuff. That's the overall picture. So in terms, just one of those graphs that you can probably guess. They started out using just Hadoop, and they used ClickView as a front end. They rapidly realised that Hadoop wasn't fast enough, so they went and they got one of the open source SQL environments, almost like a proof of concept, to show that the combination of Hadoop and SQL together would give them benefits. So they used SQL for all the right reasons on the structured stuff, and they got all the old data in there. So this is about when they went out on mobile. Yeah, there you go. So you see, that's from the data. So this scale, I don't know if you can see it back there, that goes from 0 gigabytes to 600 gigabytes, and that's the volume of data ingested per day, compressed. That's the compressed volume. So on that same graph, put in some technologies. ClickView run out of steam back there. InfoBright, which is one of these open source SQL environments, was going until it actually got to about there. And they upped, at that point they upped it to a 10-node Hadoop cluster. And then they replaced InfoBright with InfiniDB, got them along the next step, and at this point they got to 20 nodes of Hadoop and 40 nodes of Hadoop. At this point they realized these things are open source, and really, there's an issue there. It scaled to a point, but it wouldn't scale beyond that. And also, there wasn't a vendor with a fully fledged support environment, and they were basing their business on this. So they wanted to go mainstream, actually pay some money to get a product that would actually be able to scale with them. So guess what? We got, after an interesting selection process, we came down to a short step 2, and we got chosen to replace the SQL part of that environment. And then now, actually there are over 100 nodes now on the Hadoop stuff. The first EXASOL box was a 4-node EXASOL box, by the way. So one way of actually the implementation of what they were doing initially, before they got SQL, was to do this and basically use Hive to do both the ETL and to do the reporting and the data scientist stuff. Rapidly, as the data started to grow, realised that it wasn't man enough for the job. So the decision was made to actually add a relational database to do the stuff it's good at, working on the structured side of things and provide some scalability, offloading this stuff and doing it faster in here. The ETL was still in Hive at that point, because they do some transformations on this stuff as they come through. And that's when they had InfiniDB or InfoBright initially. Then they had to move on, and this is the again Andy's slide saying speed, efficiency, tuning free. This is the EXASOL thing. But they've currently got a 16-node EXASOL system, and they've got 150 terabytes of relational data in the EXASOL system. But they're looking to double that in the next month. They call us Exadudes. The people who work at EXASOL, they call us Exadudes for some reason. There you go. Why do they do it? They basically got down to a short list, and you see another Hive performance graph. They got down to a short list of EXASOL and Vertica. Vertica is another SQL database, uses data in memory techniques, parallel processing. It's marketed by HP. Good product, actually, good product. I've used it myself. But they did humongous amounts of testing, much more complex than the TPC benchmarks. And so that's the overall, the average of Hive versus Vertica versus EXASOL. And we were running on a small 4-node system. So they ended up choosing us, basically. And so what they did then, as part of their test, they were going to use EXASOL to replace that SQL backend for the analytics and let the data scientists do stuff. As part of their test, they found out the transformation process that they've been doing on Hive actually ran about between 10 and 100 times quicker on the EXASOL SQL engine. So they moved the ETL across to here. And that saved them a whole bunch of time. Just by moving the ETL processing from Hive and Hadoop across to the EXASOL box. And what next? Well, guess what they do now? They now get the event data directly into EXASOL and do the transformation there, alongside queries, and then they push it out to Hive. So Hive acts as the nearline archive storage, if you like. So the 150 terabytes of data they've got in here is the most recent couple of weeks, which is what they're focused on. And if they need to go and do some stuff where they're comparing this year and last year, then they can drag it in from here and then do that. So this is the sort of nearline archive, if you like. Kind of interesting. And it doesn't stop. They say they're looking to double the size of their EXASOL machine the next month. Great customer. Okay. A couple more slides just to finish off. Thought it was worth giving the audience to throw in a few things that I'm seeing that is sort of relevant to some of this stuff. I'd be interested to get your feedback in Q&A or over a glass of wine afterwards. Internet of Things. You've probably all seen slides like this. Getting very interesting. It's starting to become reality. We're talking to a lot of utility companies. Water companies have got sensors scattered throughout their network. Farmers who've got cows with tags on them so they can monitor the cows. Search for, if you haven't done it already, search for Internet of Cows to be made. How much data each cow generates per day. And a whole bunch of the stuff. We're talking to people who do the other Hive, the stuff with the smart home, controlling your heating and stuff remotely. Of course, that means they can gather the data from that stuff remotely as well. And they're currently doing it, I think, every every hour, but they're looking to actually up that frequency to every 5 minutes or something. Good time to be a database vendor. And medical and healthcare stuff, that's the other thing. We're seeing a lot of movement there as well. Even people like insurance companies, the people who will give you a discount if you put like a little black box in your car, so they can see how you're driving, all that sort of stuff. And everyone gets like, the old smartwatch, which will be monitoring your heart rate and blood pressure. Guess where that's going to go? Good stuff. A few other bits and pieces, wearable technologies. Google Glass, they can now, but there's going to be a replacement. Those glasses that you can see, and they can do that. Biosensors for humans and other animals, Internet of cows. Health monitoring is a big thing. But what they do with the cows is they optimise milk yields, and they try and predict disease based on things like the milk yield and the temperature and blood pressure of the cows. It can be an indicator of disease that's starting. Get it early, and it brings down the costs. Pretty much all of our clients, maybe apart from King, King's still got location-based data. A lot of the SQL environments now have got support for geospatial functions. So you can define lines and points and maps and polygons, and then you can sort of test things being inside and outside and all that sort of stuff. Suddenly, in the last probably 3 years, we've seen a huge increase in that, because people can now, and they're realising they need to. And there's things like, if you go to Regent Street, they've got these Bluetooth beacons. So if you're walking down Regent Street and you've opted into this app on your phone, and Fred, who runs Pizza Express or something down there, sees that you've eaten pizza before and you're coming down the street, and he's got a few empty tables, he might zap you a message saying, come in now and you get a £10 discount. But based on the location you walk past. And there's an interesting crowd we were talking to at the Gartner conference last week. They put cameras, replace the existing security cameras with intelligent cameras that can track people's movements through the shop. And they can't identify them right now, in theory. But they use that to actually advise the shop on positioning products within the shop. And they've started out some test cases with high street mobile phone providers. And typically they get an uplift of between 5 and 12% in revenues by telling them what to put where, based on the way people are moving through the shop, without even knowing who it is. Facial recognition, Tesco are playing with that. Don't know if that's gone with the sudden downturn. But basically, they, as you're queuing up at the checkout, they want to be able to recognise initially whether you're male or female and target the ads to you while you're still in the queue. But they're also obviously trying to match it up with your Nectar card or whatever it is they use, not your Tesco Club card, and actually give you targeted things. There's also a company who are trying to recognise whether you're feeling happy or sad from your expression as you walk past and do things. Wacky stuff. So, last slide. Cloud we probably all talked about. We're finding people are using cloud as a way of testing things. It's a very quick way of testing something, whether that's Redshift, Hadoop, or even EXASOL. They'll spin up, a certain size of cluster for next to nothing in the cloud, install EXASOL and try it out with their data. And the couple of clients are now starting to use it for dev test and even disaster recovery environments, rather than buying twice as much hardware or whatever it is. Have that out there in the cloud, ready to spin up if their SLAs are enough to allow that. Interesting. We already talked about this. R is the one that we're seeing a lot of. And this is something we've seen very recently, actually. There are a few companies worth taking a look at. They're saying that it's great getting all these nice Tableau-style visualizations and graphs, but actually what people really want to do is actually read things and get some informed narrative. And so they will sit alongside or in front of something like a Tableau and produce things like recommendations. So if you're running you're a store manager of a retail store, rather than seeing a bunch of graphs and you having to interpret that, you might get a readable bit of text that says, you should do this because, based on that stuff. And I think that's going to be a real big growth area in the next year or two. But that's, these guys are really interesting. Check out the website. So, that's the last slide. What I'm seeing basically on all this is that hybrid systems are where it's going to go. SQL won't go away, but basically people are using sort of best of breed technologies, possibly open source, but actually if they go in production they'll probably want something a bit better than that in terms of all the things you need to go to production. Basically using the right tool for the job, and the trick is getting them all to interact efficiently. That's it. Any questions, or shall we do lots of questions?
More of a request really. Some of the slides, I'm a government data scientist, I suppose is what you describe it there, but more a statistician really. But as an analyst coming at this, I'm actually having a very debate that you describe the model where you've got probably about 4 series of how actually it looked like there was system 1, 2, 3, 4, or something like that.
Right.
So one of the requests would be, are these going to be available? Because I'd quite like to use some of those as evidence, as it were, about options that
sure.
we should be thinking about considering.
Yeah.
And then the other one was really around the use of Hadoop, and one of the slides that you had about some of the types of work that you probably do in SQL quite simply, like inserts, updates, and all of those kind of activities.
Yeah.
And how you think the next 3 to 6 months, and even possibly a year, how long is it going to take for the kind of existing Hadoop Hive kind of areas to be able to catch up to those?
I think
that's quite time critical for some pieces.
Yeah, I think Hive will probably die a death and Spark will take over, is my take. And that's a huge leap in terms of Hive. But what you've also got to remember, you know, the guys like EXASOL aren't standing still. We're improving that product as well, based on a solid foundation that's been around for a while. So it's not like here's the target, all these current SQL things, and it's getting closer. These things are running fast to improve as well. So be aware of that.
Question on the ETL.
Yeah.
So it's interesting, the ETL architecturally moved.
Yes.
Does ETL become the next bottleneck? I mean, how did that change based on the nature of the data and the nature of the data source?
Yeah, well, it's for years now we've been saying in the MPP database world, even since Teradata days 25 years ago, we were saying with this stuff, actually you do ELT. You load the raw data and do the transformation in parallel on the back-end database engine. Don't do it serially on your ETL, because that's clunky. And in the same way we talked about push down in stats packages and whatever, the bigger ETL companies now do push down for these sorts of environments. Rather than doing the transformations locally, they'll generate some SQL to do the transformation you need down on that fast SQL engine. And that's essentially what's happening there. Yeah.
Just check something there. Are you saying that, I think you said it's going more ELT?
Yeah. Extract, load, transform, rather than extract, transform, then load.
I'm wearing it exactly the same.
Yeah, absolutely. Yeah. Now, King are a sort of special case, and a really good case for us, because the data coming off of their game servers is pretty structured. But even so, you know, using some of the functionality in modern SQL engines, you can do XML processing, for example, in SQL these days. You could write a UDF in whatever language you like to do some of the clever stuff. It may well be worth doing that to get the benefits of doing it in parallel on the SQL engine. I guess we're getting close to it.
I was going to say, we've got time for one more question, and then we'll have a break there. So,
Don't you see the challenge for ETL going into some product like Storm, Spark, even Stream, that are going to not do batch, but just to stream and do the processing on the stream and then push it down to some...
I mean, there are products out there now that aim to do that. ParStream is one that's designed to do stream processing. Same sort of idea as EXASOL and Vertica, use massively parallel, but really aimed at streaming event data coming in quickly and processing it before it lands it. So you don't need to land it and then process it. It's just taking it to the next level, so you can process it all the way through and then land it transformed. So, yeah.
That's great.
Okay.
Well, thank you very much, Dave. That's been very, very good.